So we're going to look at states of consciousness and sleep and how they affect us psychologically, and what we need to know as we study AP psychology about each of these things. So first, we'll tackle this concept of consciousness, which we have talked about before, but consciousness is the awareness we have of ourselves, our internal states or our thoughts and processes, and then the environment that surrounds us. So that's how we define consciousness. And then when we talk about being in a state of consciousness, it's how much we are able to evaluate the environment around us, the stimuli we see, and process that information in order to filter it out. So our state of consciousness varies and could affect those things. The most common state of consciousness is alertness, or being alert. And alertness involves that ability to stay attentive to our surroundings. So it is the ability to see what's around us, what's going on, what's happening. And it's not possible to keep this up forever. And so that varies over the course of a day. And that's part of why we need sleep and rest and those sorts of things, because our body simply cannot take the stress and the effort and the work that comes with being alert all the time. It's not actually possible. But this alertness and arousal that goes with it is controlled by a few structures in the brainstem known as the reticular formation or the reticular activation system, the RAS. And so when there is damage to the brainstem, there could be, or to this reticular formation, there could be changes in people's abilities to stay alert or to be alert at all. So that's something to keep in mind. The nature of consciousness has kind of long been argued and debated. William James, one of the first psychologists, referred to consciousness as just a continuous stream of thought that was always happening. And so that's his take on consciousness. Robert Sternberg said that it's the mental reality that we create in order to adapt to the world around us. So he sees its adaptive features, and he sees it being used to establish our personal identity and define who we are based off our ability to adapt and engage with the world around us. And consciousness serves really two important functions. First, it allows us to be responsible for ourselves, the things around us, and then our relationship with that. How do we interact with the things around us, right? Being conscious of that allows us to do that. It prevents us from hurting ourselves, from killing ourselves, these sorts of things. But secondly, it serves as a controlling role. Like, it's a way for us to plan our responses out to information that we gather by this first thing of monitoring. So we know that when I touch the pot, it was hot, so I'm going to wait a while before I touch that pot because it's hot and it's going to hurt me. So that's kind of the two important roles, is monitor the environment around us, and then plan our responses to that. And although we often think of ourselves as fully conscious, we have a few lower levels of consciousness that do exist. The first is what's called the preconscious. And the preconscious it exists in a space that is accessible to our conscious thoughts, but not always in our conscious thoughts. So this information can be retrieved when we need it. So that would include behaviors we can do without thought. The idea of riding a bicycle. Once you've learned to ride a bicycle, your consciousness, it's in your preconscious. So you can retrieve that, but you're not always thinking about how do I ride a bike. You just do it when you get on it. Same thing with brushing your teeth or any of those other types of things. You're not always thinking about it, but in the situation you are able to recall how to do it, and then you are able to do that. So that's what we have going on. Then there's also what's the unconscious, and that is part of your brain and part of your thinking that is inaccessible to the conscious. You cannot access those thoughts, but it does affect your behavior and your emotions. And this again is kind of going along with Freud's ideas. Consciousness serves as a continuum. And so we go from the most conscious, which is our controlled processes, when we are very aware of what exactly it is that we are doing. We're aware of our movement, our thinking, those sorts of things. And then it moves from that far end of the spectrum of being fully aware to automatic processes, that is tasks we perform mechanically without really thinking about it. Again, brushing our teeth, riding a bike, things like that. And this continuum then continues through daydreaming, where we are thinking about something. We're not really fully attentive to our surroundings. We're not fully aware of our environment. But in a moment, we can regain our consciousness very quickly. Then we go to meditation. After meditation, we have sleep and dreaming. And then the far end of the spectrum, as far away from this controlled process, where we're aware of what we are doing, are comas and unconsciousness, where you just have no awareness of what's actually happening around you. You are not in a state of consciousness that enables you to be aware of those sorts of things. So that's consciousness as a continuum. And we'll talk a little bit more deeply about meditation, sleeping, and dreaming as well. So sleep is one of those things, and it is an altered state of consciousness. Biologists still aren't really sure the function of sleep. There's a thought that it's a necessary restorative process, and that just seems to make sense. But if that is the case, there would have to be something that is being restored. And recent research suggests that perhaps it's melatonin, one of the neurotransmitters that is involved in that restoration process. So they're still trying to figure that out. And the need for sleep is biologically very strong. It is really difficult for people to go without sleep. It is really difficult. If you've ever tried to pull an all-nighter or go long periods of time without sleep, it wears on you, and it's very difficult. We have a drive to sleep. In general, sleep deprivation can cause major problems. You can get through one 24-hour cycle without a whole lot of issues, but by the third cycle that you have without sleep, the third 24, if you can somehow get through 24 hours without sleep, you begin to have hallucinations and illusions. If you make it through that to a fourth cycle, paranoia and other psychological disturbances can step in and start happening. What's really interesting is as soon as someone is able to sleep again, all of those symptoms just disappear. So it really points to a biological need to rejuvenate ourselves in some capacity. And what regulates that is what are known as circadian rhythms. And so our bodies follow a day to night pattern that is known as the circadian rhythm, and it lasts for 24 hours. And essentially, throughout the course of the day, various aspects of your body physiologically change. So during the night, your body temperature is at its lowest, but as morning approaches, your body temperature begins to rise. It reaches the highest point during the day, when again we are most active, and then it dips in the early afternoon, which is interesting because that's when a lot of cultures take naps, and that is again like siestas or things like that, because that is naturally what your body wants to do in that mid-afternoon. And then it drops again before you go to sleep at night. And so your body knows this rhythm, and it follows along with the sun, right? As the sun begins to rise, your body temperature increases, and then it reaches its high point in the middle of the day, and then slowly starts to drop until it drops again at night. With that said, circadian rhythms do vary depending on the individual and depending on age. So we see that newborns can spend about 2/3 of their day asleep, which is not following the normal 24-hour circadian rhythm. And older adults, they tend to peak in the morning and decline as the day goes on, where adolescents and young adults are more energetic in the mid-afternoon and late evening. Their circadian rhythms are just different at different stages in life for whatever reason that may be, and maybe there's some evolutionary reason for that. What they found is that light is super important in affecting your circadian rhythms, and why that is your retina has photoreceptors that pick up light, and that sends that information to the brain of there is light, whether that's natural or fake light, whether that's from the sun or from a lamp, some other source. That information goes to your brain, and that helps regulate your circadian rhythms. Hey, it's light outside, I should be at this time, or it's dark outside, I should be at this time. What's really interesting is when all time cues are removed, that is taking away lights, watches, clocks, televisions, other things that can point you in the direction of timing, your body tends to follow a longer circadian rhythm, and so you experience essentially longer days. What's really interesting is that people have figured this out, and so anytime if you ever end up in a casino, casinos don't have clocks, and there's always light on in there, just to disorient your sense of timing, to throw you off. So as if you remove time cues, you're able to affect the way that people's bodies cycle through. And we see this also, you'll notice that people who live in the far northern or southern areas of the earth, they try to create conditions of darkness in their summer when it's light almost all the time. They have to create conditions of darkness in order to maintain natural circadian rhythms. We see that various stimulus or stimuli can affect our circadian rhythms. The most kind of obvious or common one that we talk about is jet lag. When you cross multiple time zones, you have your body's circadian rhythm is disrupted, and it's difficult for you to respond properly to what's happening. And so jet lag generally takes about a day per time zone for you to adjust. Sleep, again, going back to sleep, it can be divided into different stages based off wavelength patterns. And so the first stage is when you're not sleeping, when you're awake. And the type of brain waves that you're experiencing when you're awake are called beta waves. Okay, beta waves. Then as you are awake but begin to relax a little bit more and kind of maybe you're becoming drowsy in the afternoon, your body is experiencing alpha waves. When you reach sleep, sleep has 5 different stages. The first stage, when you're first drifting into sleep, and in that beginning, your body experiences theta waves. Your brain experiences theta waves. Stage 2, sleep, the brain waves are called sleep spindles, and those are broken up by what are known as K complexes. So they kind of get rid of the whole wave concept and instead go with sleep spindles and K complexes. As you go a little bit deeper into stages 3 and 4, you experience delta waves. And in the last, the delta waves are more common in 4 than in 3. So they happen during stages 3 and 4, but in 4 is when the delta waves really happen. And in the last stage, the REM, or the rapid eye movement stage of sleep, your body experiences beta and theta waves. That is, the waves you experience when you're awake and then when you're drifting to sleep. And so that's why REM sleep is often called the paradoxical sleep, because it's a paradox that you are asleep, but your brain is experiencing the type of brain waves that you experience when you're awake. And so your body may be asleep, but your brain is acting as if it is, in fact, awake. And so that's kind of interesting to kind of understand, and it's something that we struggle to really get. We have, so the REM is stage 5, and then stages 1 through 4 are what's called the NREM, the non-rapid eye movement sleep. And so that's how we break up sleep into its various stages. Each sleep cycle is approximately 90 minutes long. Of course, that's not exact, it varies. And the longer you sleep, the less time you spend in stages 3 and 4, and the more time is spent in REM sleep. And so we see that we shift towards more REM sleep for whatever reason. That's what we do. And dreaming, our time to dream tends to get longer as we get closer to the morning. And those dreams are more easily remembered. So most dreaming happens in the REM stage of your sleep for whatever reason. And so that explains why as we get closer to the morning, that REM's time is extending. And so that's why it's more likely to have dreams, and you're more likely to remember those when you're awake. When people are deprived of that REM sleep for a few days, and then eventually granted the ability to sleep through the normal night, they experience what's called the REM rebound, where they have longer periods of REM sleep during the night. And so we see that it shows the importance of that REM cycle for the body, and it really reinforces our biological need for sleep. There are sleep disorders that can affect people and lead to serious problems. The first and most common is insomnia, and that's simply the inability to fall asleep or to maintain sleep. So once you are asleep, it's hard to stay asleep. You wake up often, you're restless. And this is generally caused by chronic stress, the use of alcohol, or caffeine. So it's important to keep those in mind as why people sometimes struggle to sleep. Another sleeping disorder is called narcolepsy, and narcolepsy is the inability to stay awake. So it's a little bit different, right? It's not your inability to sleep, but it's your inability to stay awake. If you have narcolepsy, you have irresistible and persistent urges to fall asleep during the day. All you want to do is just sleep. And generally, this person falls asleep for short durations. And what's interesting is when they fall asleep, it's almost all REM sleep, just for a couple of minutes. They don't go through the natural cycle of stage 1 to 2 to 3 to 4. It's just immediately REM sleep, which is interesting. And narcolepsy can be treated. The causes are uncertain, but they think that some dysfunction in the hypothalamus is one of the main reasons behind that. Another sleep disorder, and this one's particularly dangerous, is sleep apnea. And sleep apnea is when a person repeatedly just stops breathing while asleep. And this causes them to wake up because their body experiences like a minute or so without any air. And if this occurs throughout the night, and it leaves people exhausted because instead of being able to go through all the stages of sleep, they're constantly being woken up because of they're not getting any air. This is associated with obesity and alcoholism, and there's a thought that this could also be linked to sudden infant death syndrome, or SIDS, is that these infants experience sleep apnea and their body's not able to wake them up, they're not able to get any air, and they simply just die. And so sleep apnea can be a serious issue. There are ways to work and to solve that through CPAP and sleep machines. And then the last one is sleepwalking, and this occurs when an individual walks around or talks during sleep. And it's important to know that this is not them acting out dreams, because it occurs in stages 3 and 4, not REM, which is when most dreams occur. But in stages 3 and 4, it's them just having actions. And why we know that is because in REM sleep, your muscles don't move. For the most part, your muscles are immobilized. But sleepwalking, obviously your muscles, or even sleep talking, your muscles do work. And so what you were doing, though, is not just acting out dreams, but really experiencing a sleepwalking. And so that's kind of the overview of the different states of consciousness, what consciousness is, what sleep is, how sleep happens, why it happens, what our body's experiencing, and then the disorders that can go along with that can really affect people in meaningful ways.